Hi everyone, welcome you all to today's class. Today we are going to start determinants. So let me share my screen and start. Okay, so here we are, determinants part 1. So before that we already have studied what is a matrix, order of the matrix, elements of the matrix, various operations like matrix addition, subtraction, multiplication of a matrix by a scalar, multiplication of a matrix by another matrix, transpose of matrices, properties of transpose, many other things, right? So it's time to study determinants, and of course we will start with part 1. In today's class we will study what is a determinant, minors and cofactors of a determinant, evaluation of a determinant. This is in store for us today. Okay, what is a determinant? A determinant is a numerical value assigned to a square matrix. It means only a square matrix can have its determinant. Okay, if A is a square matrix, we can associate a unique expression or a number with this square matrix, which is called determinant of A, and we write it as, so determinant of A can be denoted like this or this. Suppose for example we have a matrix like A11, A12, A21, A22. The corresponding determinant we write like this. Either you write DET, which stands for determinant, or we may write like this, but be very careful here. Okay, the elements of the determinant should be enclosed within vertical bars. Okay, unlike a matrix. Okay, here you can see we are using this bracket. We may use this parenthesis also for matrix, but for determinant we have only one choice. Okay, enclosing the elements within vertical bars. And here you see, whenever we write this, no, we already have studied modulus function. So I mean, some of you may be confused. Okay, whenever you see that is how to read it, it may be mod A. No, here see, you can, whenever you practice a lot, whenever you know conceptually, like no, where to be modulus function or it is determinant, you can identify. So we read it as determinant of A or determinant A, but not mod A. Only square matrices have determinants, means non-square matrices do not have the determinants. The basic difference between the matrix and determinant is, a matrix is an arrangement, whereas determinant is a numerical value assigned to a square matrix. Okay, and of course while denoting matrix we use bracket or parenthesis, square bracket or parenthesis, but when we write a determinant we use two vertical bars. Okay, so another difference is this. Then how to evaluate a determinant of order 2. So in our syllabus of class 12th, we will be dealing with determinant of order 2 and 3. So when I say determinant of order 2, means it is the, corresponding determinant of a matrix of order 2 by 2, means having 2 rows and 2 columns. Okay, let me write here. Suppose the matrix is A11, A12, A21, A22. The corresponding determinant will be written like this: A11, A12, A21, A22. Okay, and while evaluating, what do? We multiply elements of the main diagonal, and from it we subtract product of this. Means basically A11, A22 minus 2, 1 into a 1, 2. For example, if I write here 2, 3, 4, 5, directly I am taking the determinant and I want to evaluate it. So I have to write 2 into 5 minus 3 into 4. Means 10 minus 12, which is minus 2. Okay, let me take another determinant. Evaluate this determinant cos theta minus sin theta. Here sin theta, here cos theta. So it is the question from your NCERT book, 4.1 exercise. Cos theta into cos theta, cos square theta minus sin theta into minus sin theta. Means minus of minus sin square theta. It's plus sin square theta, which is 1. Okay. And if I take another example, like suppose, for example, evaluate, question is, evaluate the determinant x square minus x plus 1. Here x minus 1, x plus 1, x plus 1. So evaluate this determinant. Then we have to take x plus 1 into x square minus x plus 1 minus, here it is x plus 1 into x minus 1. Okay, so x cube minus x square plus x square minus x plus 1, here minus x square plus 1, right? So this is cancelled. We can calculate quickly. So we are getting x cube minus x square plus 2. Okay, this is the value of the determinant. So because the determinant contains all the variables here, we are getting such expression. So elements of a matrix and also the determinant, okay, can be a real number, it can be a complex number, or it can be a function. Okay, so this is how we evaluate determinant of order 2 by 2. Now, before we step into the evaluation of determinant of order 3, we need to know certain terms, minor and cofactor. So, minor of the determinant or minor of the elements of a determinant, what is it? Let me take a simple example here. Okay, let me write here A, B, C, D. Okay, 2 by 2 determinant. Now, here this element is element of first row and first column, means A11. So minor of A11, we write like M11, which is to get M11. What we need to do? We will not consider first row and first column. It means suppressing the first row and first column and taking the remaining element. Okay, M12 element of first row, second column. So M12 is the minor of the element of first row, second column. So first row, second column, first row, this second column will not take. So we will be left with C. Okay, M21 second row, first column. Suppress this or delete this or remove this. So you are getting B here. And finally M22 minor of A22. Second row, second column. Except second row, second column, you take the remaining element. Yeah. Done. Okay, let me take, yeah. So if I write here 2, 0, 1, 3, 1, 4, then I can write here 3, minus 1, 2. Okay, this is a determinant. I'm taking here determinant of order 3 by 3. Okay, so 9 elements. So we will have 9 minors. Okay, so start with M11, minor of A11. So first row, first column. Delete this. Delete means you do not consider this. So except first row, first column, yeah, removing first row, first column, you consider remaining elements. Okay, 1, 4, minus 1, 2. Okay, so determinant of this. So we know how to evaluate this. 2 into 1, 2, minus minus 1 into 4 means plus 4. 6. M12 first row and first row and second column. So first row, this is first row, second column. So except the first row we will not consider, second column we will not consider. You see, we are getting 3, 4, 3, 2. So this is equal to 3, 4, 3, 2. Okay, consider this determinant. 6 minus 12. 6 minus 12 is minus 6. So like this, you can consider minors of all 9 elements. Okay. So how to find it? Just let me read out the definition. If we take an element of a determinant and delete or remove, or you can write suppress. Okay, suppress. Just a moment. Okay, so you can write delete or remove or suppress or do not consider the row and the column containing that element. The determinant of the element left is called minor of that element. And Mij denotes minor of Mij. Mij denotes minor of Aij. Okay. So this is the way we can find minors of elements of the determinant. Okay. Next, cofactors. So cofactor of an element Aij denoted by Cij. It is defined by Cij equal to minus 1 power I plus j into Mij. Okay, whenever we write the elements, suppose I write A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, this is a determinant. Okay, whenever we write Ij, obviously row index and column index we are talking about I plus j. Like for here you see I plus j, 1 plus 1, 2. I plus j, 1 plus 2, 3. I plus j, 1 plus 3, 4. It means for all the elements I plus j, we are getting either even or odd. So when I plus j even, minus 1 power even is plus 1. So cofactor equal to minor. Right? And whenever you have I plus j odd, so minus 1 power odd number is odd. Sorry, minus 1 power odd number is minus 1. So minus 1 into its minor, into minor of the element. So you are getting minus of Mij. So cofactor of Aij equal to minor of Aij if I plus j is even. And minus of Mij or negative of minor if I plus j is odd. So for A11, minor will be M11. So here cofactor C11 equal to M11. And for C12, it is minus of M12. C13, it is like minor of, plus this, like this. And similarly, C21 minus of M21, C22 equal to M22, like this. So you are getting like plus minus plus minus plus minus plus minus plus. So alternately you are getting like this. So plus means cofactor equal to minor, minus means cofactor is negative of minor. Okay, so we can take the sign convention like this. Okay, so next how to evaluate? Let me find the cofactors. Find the cofactors of the elements of determinant of A. So let me take a 3 by 3. 2, 0, 1, 1, 7, 9, minus 1, 3, 2. Okay. So let me just take it. Okay, just. Okay, so 9 elements, so we will be getting 9 minors and of course 9 cofactors. Done. Okay, so to start with cofactors, so we can write here C11 means cofactor of 2. C11 equal to M11. So you will not consider first row, first column. Okay, so this one first row, first column you will not take. So 7, 9, 3, 2. So you are getting 14 minus 27. So you are getting here minus 13, right? C12 minus of M12. So minus of, be very careful here regarding plus minus sign. So first row, second column we will not take. So 201 we will not consider, 079 we will not consider. 19 minus 12. 19 minus 12. So it is minus of 2 plus 9. Okay, you're getting minus 11 here. C13 means it is M13. First row, third column, we will not take first row, third column. Delete this. 17 minus 13. 17 minus 13. That is equal to 3 plus 7, 10. Okay, similarly, this last one, C21 minus of M21. So this is the way you can find. The second row, first column. Second row, first column, you will not take, right? So you are left with 0, 1, 3, 2. So minus of 0, 1, 3, 2. Just be very careful about taking order of the elements. Like here you see, second row and first column we are not taking. So 0, 1, 3, 2. Then we are getting 2 by 2 determinant here and we can do it. So it is 0 minus 3. Minus 3, minus of minus 3 is plus 3. Okay, and through practice you can be able to find cofactors and minors even directly. Okay, the speed can be enhanced through practice. And in the beginning, maybe you may follow like this, and after certain time, even questions you can be able to do it very quickly. Even we don't have to mention this determinant thing, you can do directly. Okay, after knowing minors and cofactors, then evaluation, expansion of or determinant of order 3. Okay, so determinant of order 3. The rule is a determinant can be evaluated, or you can say expanded from any one row or column. So in case of 3 by 3 determinant, you have 3 rows and 3 columns. So you can expand the determinant either from R1 or from R2 or from R3 or from C1 or from C2 or from C3. So out of 6 options, you can choose one. Okay. A determinant can be evaluated or expanded from any one row or any one column. Second rule is, like suppose whichever row or whichever column you want to take. For example, you want to take first row. Okay, suppose I write here A11, A12, A13, A21, A22, A23, A31, A32, A33. I want to expand this. If I decide, I will expand from here, first row. So it means here I can write A11 C11 plus A12 C12 plus A13 C13. It means I am taking here the elements of the first row and the corresponding cofactors, and I am considering sum of the products of the elements and the corresponding cofactors of the first row. Okay, or what I can take, if I decide to take second row, then what should I do? Then here I can take A21 C21 plus A22 C22 plus A23 C23. Okay, so whichever row or whichever column we want to take, we have decided. So we have to consider elements and the corresponding cofactors, right? And take the sum of the products. Or in general, it is basically what? Sum of the products of Aij, Cij. Okay, so it means any one row or any one column, right? So I from 1 to 3, J from 1 to 3, but you have to take only one row or one column. And as we know, cofactor cannot be found directly, I mean without minor. So what we are doing, like this thing can be written as A11, M11, because C11 equal to M11. C12 equal to minus of M12, because here I plus J is odd, cofactor is negative of minor. So we can write here minus of A12 M12. Again here cofactor equal to minor plus A13 M13. Okay, if I consider this one, C21 equal to minus of minor. So minus A21 M21 plus A22 M22 minus A23 M23, like this. So it means again here sign convention goes like this, plus minus plus minus plus minus plus minus plus. Okay, so it means plus means cofactor equal to minor, minus means cofactor is negative of minor. But while evaluating, though we take this formula as per mathematical definition, but cofactor cannot be obtained directly, I mean without minor. So we use this one. So instead of going like this, no, usually we go like this. So but you have to see any whichever row or whichever column you want to take, no, you have to take sum of the products of elements and the corresponding cofactors of that row or that column. Okay, I will take some examples also. So you have 6 options, as I said, first row or second row or third row or first column, second column, third column. It is up to you. Okay, you are given this choice. Okay, so evaluate. So let us take some questions. Yeah, if A equals to, I mean determinant of A, it is equal to 1, 1 minus 2, 2, 1 minus 3, 5, 4, 9. Okay, or I may write here, just a minute. It is a question from the NCERT book. Suppose you are given, yes, you are given this is the matrix given to us. Okay, find determinant of A. So we can write like this, determinant of A, 1, 1 minus 2, 2, 1 minus 3, 5, 4, 9. Okay, this is the determinant we want to evaluate. Okay, so we can write here, suppose expanding from first row. You can take any row or any column. So if I take first row, so 1 into minor. Okay, so I'm writing, because it is the first question, I'm writing like this. So 1, the minor is, we have to take A11, A12, A13. So this is the background work you have to do. A11, C11 plus A12, C12 plus A13, C13. Okay, because we are taking first row, so elements of the first row and their cofactors, corresponding cofactors. Or this is equal to what? A11, M11 minus A12, M12 plus A13, M13. Okay, now A11 is 1. What is M11? First row, first column. We will not take 1 minus 3, 4, 9. Okay, minus A12. So here A12 is 1. So minus 1 into here M12. First row, second column, we will not take 2 minus 3, 5, 9. 2 minus 3, 5, 9. Okay. Then plus A13 into M13. A13 is minus 2 here. So minus 2 into M13, first row, third column. We will not take 2154, 2154. So this is equal to 1 into 9 plus 12 minus 1 into 18 plus 15. Okay, minus 2 into 8 minus 5. You can directly do from this step also if you are, very confident or you think you can do it. And later on we have to do like this only. Not every time we do not write the determinants. It is matter of practice. So 1 into 21, 21. Then minus 33. Yes. Then 8 minus 5, 3. So you are getting minus 6 here. Yes. So you are getting what? 21 minus 39 means you are getting 8. Okay, minus 18. Okay, this is the value of the determinant. So if I write one more, like suppose 201, evaluate. And here I am writing directly 203. Okay, minus 1, 2 minus 5, 2 minus 1, 0. 2 minus 1, 0. Okay, and how quickly we can do it. Suppose I want to take first column contains 1, 0. So it is wiser to take like this so that we can have less calculation. So I'm expanding this from first column. So 2 into minor of this. So A11, M11, right? So minor of this means 2 into 0, 0 minus 0 minus 5 minus 1. Okay, then here it is minus 0, then plus 3 into, now here you can write 3 means you don't have to take this row and this column. So 1 minus 4. So this is the way to do it quickly also. Okay, this is minus 10. Here it is, minus 3 plus 3. Minus 9. That is equal to minus 19. Okay, so basically, once you are familiar with the process, specifically minors and cofactors, so you can be able to do it very, very fast. Okay, only thing is you have to keep in the mind, it is the sum of the products of the elements and the corresponding cofactors of any one row or any one column. Okay, and because for cofactors, we have to see the minors. So like this. So once you are doing this unmistakably, evaluation of determinant is complete. Okay, so I think we are good to go now. It's this, I think it's the end. Yeah, so this is the way we can evaluate the determinants. So next we can come up with determinants of, we can say, some properties, and also we can come up with determinants part 2. And this stop sharing.